I'd like to welcome you to this, our seminar on the recent changes to Part L, Part F, Part O and Part S of the building regulations. I'm Terry Keach, I'm equity partner for Calford Seedon, and I oversee all of the M&E and sustainability for Calford's. Our presenters today, Karen and Vicky, who are the first up, are going to be giving you information on Part F. Then followed by Salah and Mo, who will be giving you information on Part O. Then to Emily and Marie, which will be giving you some information on Part L, and then finishing with Tom, giving some information on the new Part S, so a new regulation coming into the building regulations. Next slide, please. So say there, our agenda then is to cover those four main areas: Part F, for ventilation, Part O for overheating regulations, Part L and the changes and the SAP updates that have just been released, and then approved document Part S, which is for electrical vehicle charging. Next slide. Very, very quick buzz through us. We're a multidisciplinary consultancy. We've been trading for around about 80 years now, so we've been on the scene for some time. Our vision, as you can see there, is to become a trusted provider of high quality professional services to a whole range of clients and service areas. Next slide. As I say, our multidisciplinary areas, as you can see, we probably cover all of the consultancy services in construction. Today, the services that are going to be used are our sustainability and M&E departments. But as you can see there, we have a wide coverage of all of the areas for construction. Next slide. Our sectors also: commercial, industrial, community, education, healthcare, residential, retail and senior living are all fully covered by Calford Seedon. Today, our building regs seminar is going to really touch on the areas of mixed use and regeneration. It's going to touch on residential, and it will have relevance for senior living. So they're three of the main areas that our building regulations seminars will pick up today for you. Next slide. Just to let you know and to see our validation and competency areas through our membership and affiliations. All of our presenters today are part of CIBSE or the IET, the Institute of Energy and Technology, or the Institute of Energy. So those are the areas we cover. Obviously, across the wider areas of Calford Seedon, REBA, RICS, BREEAM and the associated memberships are also fully covered. Next slide. Our locations, our offices: London, Birmingham, Cambridge, Essex, Kent and Hampshire. Our team today that are going to be giving the presentation are coming from our London office, our Birmingham office and our Kent office. I'll introduce each one as they come through. But next slide. And we'd like to really kick off the seminar now, starting with Karen and Vicky, and over to you two guys.
Thanks, Terry. Good afternoon. So I'm presenting with Vicky from the London office. So Part F has close links with Part L and Part O, with improvements towards the Future Home Standard. So it was issued in 2021 and it's now much easier to read. It's been put into 2 volumes: Dwellings and Buildings Other Than Dwellings. Next slide, please. The document runs through the ventilation provision requirements, what's changed and the impact, minimising the ingress of pollutants, which has been brought into the main body of the document rather than an appendix, work on existing buildings and when to consult Part F, and commissioning and provision of information and what's required here. Next slide, please.
To ensure good levels of indoor air quality, we must take in consideration the best method of ventilation for the building. There are three types of ventilation which must be provided: background ventilation in the form of trickle vents or continuous ventilation, ventilation, natural or mechanical, to deal with moisture, odours and air quality, and finally purge ventilation for quick removal of odours, for example when you burn your toast.
Background ventilation is trickle ventilation, and it's now on a room by room basis rather than per dwelling. And free areas have to be marked on the ventilator and visible inside the property for inspection. Whole house ventilation rates, biomechanical ventilation with heat recovery, have increased across the board. So now a 5-bedroom property
You've just put yourself on mute by accident.
I didn't touch anything. Okay, we'll go back to whole house ventilation, which has increased across the board. So 5-bed property has increased from 29 litres a second to 43 litres a second. And this can lead to an increase in duct sizes from to 220 by 90 millimetres for main ducts, which can impact on larger ceiling voids, terminals and possible attenuation. Next slide, please.
So all new buildings now require air permeability tests to assess the air permeability. This can impact the cost and programme of the project.
Air permeability is the infiltration of the building. It's uncontrolled cold air entering around gaps and through around windows and junctions, and is more common in old buildings, but it adds to the heating load.
So natural ventilation, intermittent extract to wet rooms with trickle ventilation, can only be applied to buildings with higher infiltration rates. So at early design stages, we can design to 5 meters cubed per hour per meter squared at 50 pascals. However, at construction, this has to be above 3 meters cubed per hour per meter squared at 50 pascals. If it fails, the property has to have continuous mechanical extract ventilation installed.
Part L, as we'll hear from Marie later, is pushing to reduce the heat load of the building by reducing the air permeability, and therefore mechanical ventilation with heat recovery is favourable as it recovers the heat from the extracted air and puts it into the incoming supply air, thereby reducing the heat load and providing continuous mechanical ventilation without the cold infiltration, allowing for a tighter sealed building. Next slide, please. There's more emphasis of this in this update, so minimising the ingress of external pollutants, with limiting values brought into the main document. So we have to take care when building adjacent to industrial areas or large roads, which could limit the opening of windows and impose mechanical ventilation with filtration.
So air quality and acoustic surveys are required early on in the design stage to inform the strategy. This impacts the possibility of not opening windows at all, which would lead to mechanical ventilation with filtration and attenuation. As access is required to the plant for cleaning filters regularly, purge ventilation is 4 air changes. So a normal boosted ventilation system is just over 1 air change. This is 4 times what we would normally propose, which potentially could be a whole separate system. Another important factor to mention is the implication to overheating, which will be explored in the next section by Mo and Salah.
When working on existing buildings, we would expect that when adding a wet room or a habitable room or replacing the ventilation unit, that we'd consult Part F. But now, when retrofitting your existing stock to pass 2035 or 2030, you'll be making improvements to the air tightness through draft sealing, window replacements and improved insulation, and these can impact on the background ventilation rate, and Part F needs to be consulted.
There is a risk chart below that helps determine whether the alterations impact on the existing ventilation system or not. Next slide, please. So commissioning and inspection has now been included into this document. It's more prescriptive and it can be found in Appendix C. Commissioning of airflow rates to be recorded and demonstrate that the ventilation system is operating as intended for all items, including cooker hoods. Controls must be labelled to indicate their function, and the quality of supply and extract valves is important to maintain the commissioned flow rates. For example, a screw-in one can be altered if taken off for cleaning or decoration. Lockable ones, therefore, will ensure flow rate is maintained. Inspections must take place to check that background ventilations are adequate for the room and property, and ventilation operates correctly and the controls have been set accordingly, and no noise levels are acceptable.
For operation and maintenance, the home user guide is key and will be referenced by Salo in a later section. And this will include a jargon-free, non-technical operation and maintenance instruction, which is given to the owner-occupier. It includes how and when to use the ventilation system, the importance of keeping it switched on, location of controls, settings, cleaning and maintenance, and also design flow rates, which is Appendix C. Next slide, please.
So early considerations, which are very important, are for air quality and acoustic surveys, checking that we've got adequate ceiling voids for any increase in ventilation ductwork, and aiming for low air permeability to reduce the heat loads in line with Part L.
With the improvements of airtightness and a drive to reduce CO2 emissions from dwellings, the installation of mechanical ventilation, in particular mechanical ventilation with heat recovery, ticks the box for background ventilation, general ventilation and possibly purge ventilation if the external pollutants and noise prohibit the opening of windows.
This also de-risks the air permeability coming in below 3, which was designed originally for 5. Allowing time in the programme for air testing, commissioning and inspections, and providing the ventilation jargon-free operation and maintenance information within the homeowner user guide.
We now hand over to Mo and Salo with Part O, who will emphasise the implications of overheating.
Good afternoon, all. I'm Mo Khan. I will be talking about Building Regulations Part O. Next slide, please. The purpose of Part O is to mitigate the risk of overheating in residential buildings, and in particular new residential buildings, by limiting solar heat gains and applying practical strategies for the removal of excess heat. Part O in particular emphasizes on the usability and practicality of overheating mitigation strategies. It is worth mentioning here that TM 59 2017 overheating assessment methodology still applies to the existing residential buildings, and for non-residential buildings, it's CIBSE TM 52 2013 criteria. There are two methods of compliance for Part O: simplified method and dynamic method, and I will be talking more about these two methods in the coming slides. Next slide, please. Simplified method of Part O is more of a prescriptive or checklist-based assessment method. For the simplified method, the strategy to reduce the risk of overheating should be selected according to the location of a residential building, whether it's located in a high-risk area or a moderate risk area, and whether it has cross ventilation or not. There are two categories of risk locations: high risk location and moderate risk location. So, for example, if a building is located in a moderate risk location and it has no cross ventilation, so looking at table 1.2, for example, if you want to look at east elevation, the maximum glazing area on the east elevation shouldn't be more than 18% of the total floor area of the building. And for the most glazed room, the glazing area shouldn't be more than 26% of the room's floor area. Similarly, openings should be designed to achieve or exceed the criteria for the minimum free area given in table 1.4. Simplified method can be applied in high-risk locations with some additional shading methods, namely external shutters with means of ventilation, or limiting the G value, or applying overhangs on windows. However, we should be mindful of limiting the G value, as this can be beneficial in summer, but it can have an adverse effect during winter time by increasing the heating load and reducing the daylight. So here's a link between Part O and Part L. and my colleagues Murray and Emily will be talking about this part of part L in the coming slides. Simplified method, it's not suitable for multi-residential buildings which contain communal heating and hot water system. In this case, we apply a dynamic method, which is more detailed and involve computer-based simulation and modeling. Next slide, please. Dynamic method of Part O, it adopts the CIBSE TM59 2017 methodology. However, Part O applies some limits on the window's opening profile, and it also clearly mentions the noise intensity threshold for bedrooms, which are 40 dB average and 55 dB max during the sleeping hours from 11 p.m. to 7 a.m. If this threshold is exceeded, then we won't be able to open windows for ventilation, and alternative methods, either by mechanical means or acoustic lures, could be considered. However, we should check this with the Part O compliance, that the minimum free area or the ventilation rate is available for purge ventilation to these rooms. Internal blinds and external tree covers cannot be applied for Part O compliance. And entrapment, the window sill height should be 1.1 meters or above, and the for outward opening windows, the opening distance shouldn't be more than 650 mil. I will now pass on to my colleague Saleh, who will talk further about Part O and the practical strategies for limiting solar heat gains and for the removal of excess heat from buildings. Thank you.
Thank you so much, Mark. So now I'm talking about the practical strategies to limiting the solar heat gain. So as my colleague said, so internal blinds are not permitted within the new Part O. So then we have to work on the external shutters or external blinds to reduce the solar gains to get into the rooms. Also, the other parameters which we can work on is the glazing design aspects, where the ratio of the windows, the size of them, and the location of them can be changed. But then we have to make sure that it's not going to impact the daylighting factor. Also, the G value could be reduced to meet the overheating mitigations, but then again we have to make sure with the Part L and the SAP assessment that because the lower the G value, higher the heating demand, so we have to also make sure that the other part of the building regulation is not going to get violated through when we're doing the overheating assessment. Could you go to the next slide, please? So now I'm talking about the practical strategies to removing the excess heat. So there are two types of the gains. One of them is through the solar gain, so from the outside into the rooms, and the other one, the internal gains, which can be caused by the equipment or the communal heating pipe works through the corridors. So there are two measurements, the passive measures and the active measures. So the passive measures are basically having the windows open, so to benefit of the natural ventilation, or having the ventilated louver, which again, it gives us the better air to the rooms and reduce the solar gains. And the active measures where the mechanical systems get involved, and either the MEV, which is only extraction, or the MVHR have the benefits to supply and extract the air from the rooms. If those two options again are not permitted or not helping us to reduce the chance of overheating, then we can use the cooling modules or the comfort cooling, which would be the next steps. If you can go to the next slide. Now I'm talking about the delivering in practice and usability. So part O emphasize on the workability and the practicality of the adopted overheating mitigation strategies. And it also emphasized for this purpose, it is important to engage with the architects, acousticians, and the wider design team like the MEP designer as early as possible, because any changes during the design aspect will impact the rest of the team's design, and then everything should start from scratch. And it should be also made sure that the adapted overheating mitigation strategies is not violating the other building regs in such as like a part F and a part L. And the acquisitions and the air quality assessor should be on board as early as possible, because their assessments and the reports will impact the overheating and could cause an alteration into the modeling. Also, if the additional mechanical ventilation is required, then the services voids and the dock sizing, if it gets changed, should be discussed with the MEP and the design team. And part I also emphasize, it is a great opportunity to engage with the residents, to educate them on the mitigations measures, and also to make sure they are aware how to keep the internal atmosphere cool and how to make sure they are mitigating the risk of overheating. Now I'm passing you to my colleagues Emily and Mary, and they will discuss about the part L and SAP. Thank you.
Hello, I'm Marie, and myself and my colleague Emily are going to talk about the updates to Part L 2021 and to SAP. Next slide, please. So here we have the updates that have come in. One of the main ones is the introduction of the target primary energy rates to the minimum performance targets. The new target primary energy rate measures the energy used within the fuel. Also, there is the air pressure tests. These now have to be done on all units, and they have now been that's now been reduced to the maximum level of now 8 meters cubed per hour per meter squared at 50 pascals. Next slide, please. So here we have the transitional arrangements for the new Part L. So as long as building notice, initial notice or plans was deposited with the local authority by June 2022 and work begun on all buildings by June 2023, then Part L1A 2013 would still apply. However, if works have not begun on buildings by June 2023, then they'll be under the new Part L. Therefore, in some cases, developments may have dwellings under the different regulations. Next slide, please. Here we have the notional dwelling specification for Part L 2021. Some of the main bits on here is the uplift to the U values for the roofs and windows, the introduction of wastewater heat recovery, and the assumed PV is installed to all units. It's also the target emission rate, target primary energy rate, and the target fabric energy efficiency rates for all new dwellings are now used to calculate are now used by the dwelling specification to calculate these.
Thanks, Marie. And one thing to note on this slide is the glazing G values. So that's the solar transmittance, as Mo and Slair outlined earlier. So we can see that the notional building uses a G value of 0.63. So that's assuming that you get 63% of solar gains into your dwelling, which is fantastic for heating because it reduces your space heating demand. But as Mo outlined earlier, this does have a significant impact on the overheating. So it's almost getting a balancing act between Part L and Part O. So you might be looking to reduce, especially around London, you might be looking to reduce that solar transmittance or G value to around 0.5 or 0.4. So that has a really bad negative impact on the dwelling fabric energy efficiency and makes it difficult to achieve that target fabric energy efficiency rate. So you'll be looking to make improvements elsewhere to your building fabric, such as triple glazing with a window U value of 0.8, reducing down your air permeability from 5 to 3, and also concentrating on those thermal bridging junctions to make sure you insulate them as much as possible to reduce any cold bridging. So on the fabric energy efficiency, the windows, air permeability and thermal bridging have the biggest impact and really should be concentrated on during the early stages of the design. Next slide, please.
So here are some of the key impacts for Part L 2021. The calculations for the distribution loss for communal heating. So in SAP 2012, the distribution loss was typically based on 5%, but from SAP 10.2, there are now 2 new default heat loss factors. These are 1.5 for compliant systems, so CIBSI CP1, or 2 for non-compliant systems. It's important to ensure that the distribution pipework is fully insulated for both primary and secondary pipework from block entry point to dwelling. The secondary pipework contributes most to the heating losses and can also lead to an overheating risk within corridors for communal areas. The updates to the thermal bridging and thermal mass parameters is that we can now no longer use accredited construction details or ACDs. It's now only possible to use the default values, user supplied side values, or a mix of both to calculate the thermal bridging of the dwellings. It's also this is to get a more accurate assessment. Side values need to be calculated from alternative schemes such as insulation manufacturers, or to have bespoke side values calculated for each cold bridge. This is to help to reduce the performance gap between what is designed and what is actually installed. For the thermal mass parameters, the use of simple calculation has now been removed, and we now have to perform a precise calculation on all internal walls, including internal partitions. A new requirement is for photographic evidence to be provided for each unit. These now need to be taken during the construction phase for each of the building details and the thermal and the cold bridging. These need to be unique for each dwelling, and the image file needs to include the plot number, the detail reference, and be digital and of sufficient quality to allow the audit of that detail. These need to be sent to the assessor throughout the construction phase so that we are able to point out any areas that may need to have photographs retaken to enable them to go through the audit process. If left to the end of the construction phase, we won't be able to assist in ensuring that they meet the evidence requirements. Next slide, please.
Thank you, Marie. So here's a graph showing the estimated cost of heat. So that's your pence per kilowatt hour of heat. Using the prices for mains gas and electricity in the SAP 10.2 document, the price cap in April 22, price cap in October 2022, and then also the energy price guarantee in 2022. And the pink line shows the cost of heat when using the boiler with a 92% efficiency, and the green line shows the cost of heat for an air source heat pump with an efficiency of 250% or COP of 2.5. So for that air source heat pump, that assumes that you put 1 kilowatt of energy into it and get 2.5 kilowatt of heat out. And we can see, due to the cost difference between mains gas and electricity, even though the air source heat pump is so much more efficient than that of the mains gas boiler, the cost of heat can still be higher compared to mains gas. Therefore, this is why we're pushing to insulate our homes and drive a passive design to try and reduce that space heating demand, and also focus on the hot water as well, because the hot water demand is typically higher than that of the space heating, and it's just trying to drive down the energy for that. So looking at your fixtures and fittings. Next slide, please. So as I just said, some early considerations here. So driving for passive buildings, so looking at insulating, low air permeability rate, concentrating on your thermal bridging junctions, so making sure we insulate those junctions, like where your external wall meets your ground floor or your intermediate floor. Look at externally supporting balconies instead of cantilevered, because that has quite a big impact again on your target fabric energy efficiency rate. Also in the block of flats, where you may have walls adjacent to unheated spaces such as corridors, staircores, bin stalls, and also floors above those unheated spaces as well, looking to achieve U values similar to those in the notional dwelling specification or better. So really concentrating on the installation around those areas.
It's also good to consider bringing on a sustainability consultant as early as possible to go through an assessment for summer overheating, and also for the installation of heat recovery technologies such as mechanical ventilation with heat recovery and also wastewater heat recovery systems. I'm now going to hand you over to Tom for him to go through Part S. Thank you.
Thank you. Good afternoon all, I'm Tom Masters, and the final set of slides will be based on approved document S of the building regulations, the infrastructure for the charging of electrical vehicles. Next slide please. There are a number of requirements for different applications stated within Part S. However, for this presentation we'll concentrate on requirements S1 for new residential buildings. With a few exceptions, buildings undergoing these works will require a minimum of an installation of a 7 kilowatt untethered EV charger or cable routes capable of providing the supply. However, 7 kilowatts will roughly provide around 30 miles of range per hour of charging. Due to the climate change, governments and manufacturers are wanting to move away from internal combustion engine vehicles. The UK is set to ban the sale of all new cars using internal combustion engines in 2030, and almost all major manufacturers have committed to either stopping production of these cars altogether or to offer a pure electric alternative in the near future. The purpose of Part S is to ensure infrastructure matches ambition when it comes to investment in EV technology. Approved Document S did take effect from June 2022, so it does not apply to the work subject to building notice, full planning applications or initial notice submitted before that date, provided that the work is started on site before the 15th of June 2023. Next slide please. What are the installation requirements? So the requirements for EV charging previously under the GLA's London plan was for provision of 20 active chargers and 20 passive. The Part S requirement now exceeds the GLA recommendations. EV chargers are required to suit the number of parking spaces equal to the number of dwellings, or where there are fewer associated parking spaces than there are dwellings contained in the residential building. All parking spaces require EV chargers. If the cost exceeds the average cost cap of £3,600 for all work involved in the installation of a charge point, then only the cable routes themselves need to be installed. Where the cost of this is more than 7% of the total cost of the major renovations, there is no requirement to install either electric vehicle charge points or the cable routes if the cost of the cable routes is more than 7%. Cable routes for electric vehicle charging points must be installed in associated parking spaces which do not have an electric vehicle charge point. This applies to developments with greater than 10 parking spaces and that there are more associated parking spaces than there are dwellings contained in the residential building. In terms of electrical supply capacity, the existing infrastructure and supply upgrades need to be considered. Initially, electrical load assessments will clarify what substation provisions are required, and applications with the district network operators will have to be made to clarify what local networks can be supported. It is worth highlighting that UKPN recommend that diversity is not applicable to EVs when calculating the electrical load. This means that the electrical load of the site will be high when making the applications to UKPN, which will increase the likelihood of substations and local networks having to be carried out, which will increase project costs. The minimum standard for an EV charging point is that they are designed and installed as described in BS EN 61851, the IET design guides and BS 7671 requirements. EVC charging points are best positioned in the corner of a parking space to suit the use of dual chargers. Part S describes the minimum spatial requirements for wall and floor mounted chargers, complete with free space to access. So preparation for car park layouts will need to be considered early on to establish planning for EVCs and sufficient space around them. Next slide please. So, what's the solution for EV charging? It is essential that early stage electrical load assessments and network analysis is carried out, so substation considerations can be established and the implications this will have on the project's design and costs. Both dual and single EV chargers are available on the market, so here are some examples on the slide. Each have their own benefits, however, a minimum rated output of each charger has to be 7 kilowatts per point. Array charging should be considered as it allows more chargers to be fitted that would normally be the case, as each charger will derate as necessary to never overload the incoming mains feed. So the future of smart charging is currently moving towards utilising off-peak, low-carbon electricity. When permitted by the user, the charging of an EV can be paused or the rate of charge increased or decreased in the response of the commands received from the energy network operator. Technology innovations are currently being developed to look at vehicle-to-home and vehicle-to-grid charging. Vehicle-to-home charging uses the electricity in the vehicle's battery when it's been charged during off-peak hours to act as a storage device for the home when the prices are high. Whereas vehicle-to-grid is the selling of the energy stored by the electrical vehicle's batteries back to the grid to mitigate any short-term overloading. I'm going to pass you back over to Terry now, so next slide please.
Thanks, Tom. Much appreciated, and thank you to all the presenters for giving your slides. I think I just wanted to finish on the fact of the common thread in the 4 regulations that we've looked at: Part F, Part L, Part O, and Part S. Obviously, with F, L, and O, that emphasis, I think, that Marie and Emily referred to on the passive design and passive performance of buildings. It always has been important, and it always has been massively important that we concentrate on the envelope of the building before we ever concentrate on what the technologies we put in. But I think the building regulations and tying that common thread that runs through ventilation, fuel and power and overheating really emphasise now the amount of effort that we need to put into the facade of the building and the way that the building works. And you may say, well, you know, Part S, how does that work into that common thread? Well, again, it has the element of the sustainability and the drive towards electric cars. But what is important, and we've seen it massively, and I think we all have from Part L and the changes to SAP, is that where we are now looking at electrical technologies as being the renewable standards that we're using within our buildings, and working towards the future home standards in 2025, and then the removal of boilers, gas boilers onwards from 2030. You can see that drive for electricity, along with the drive to electrical vehicle charging, is also going to mean that the early stages of the project is really looking at our electrical infrastructure on all of our projects. Whereas in the past, it may have been at certain developments, a transformer wouldn't have been having to be considered, or strengthening of the electrical network. It now becomes a really critical one very, very early on, especially if on the Part O area, that the way that it has to be tackled when you can't tackle it passively is to do it actively with cooling. We're hoping that in most, if not all cases, it can be dealt with in a passive manner, but it's just doing that early indication of realizing that, you know, not only are there the elements to the passive facade of the building, but thinking about that electrical use for the future. And finally, because all the way through this Calford Seedon in looking at what we've tried to do with sustainability, it has to be sustainability with affordability, and fuel poverty now, obviously more than at any other time, has become really key to us. So the more we can reduce energy within our buildings, the more we can allow residents to really get the benefit from the way that we can passively design, means that we can really make inroads into assistance with fuel poverty and help people, as opposed to just looking for a technical solution on all of those bases. So that common thread I see building in the building regulations only really gives that emphasis to the way that we should be looking at our buildings in future, and our drive towards the future home standards and our drive towards zero carbon, making that as much as we can through a passive environment. we're going to finish it there, and we're going to finish the slides there. We're going to open it up to questions now. If anyone does have any questions, if you want to use the raise your hand, the yellow raise your hand section, please feel free to come on and ask the question.